Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for January 13th of 2024 is titled Circling the Sun. So what do we see here? Well, here we see a circle around the sun. Now, the circle itself is actually caused by our atmosphere and is a 22-degree halo. So that extends 22 degrees in diameter, so 11 degrees away from the sun in every direction. Now, that is caused by ice crystals within our own atmosphere. If we had no atmosphere, you would not see this. So an observer on the moon looking at the sun would never see this type of halo around it, because it requires an atmosphere in order for it to be visible. And we can see it here. And in fact, we can see more detail depending on exactly the conditions in the atmosphere. We can see far more things than just the halo around the sun. So we can also see far more detail, things like sundogs and other types of arcs that can also be visible around it as well. Now mentioned in the description for this is also that while this is a circle, the Earth's orbit around the sun is not a circle. And what the orbits of the planets are ellipses. So an ellipse you can think of as a squashed circle, something that's flattened a little bit. Now in reality, they don't differ that much from a circle. And if you drew a big circle around and then drew one of the planet's orbits to scale, looking at them, you would not be able to really tell the difference between the circle and the orbit. They would look almost exactly the same. The planetary orbits are very close to being circular, which is one of the reasons it took us so long to be able to understand that they were not elliptical, but were indeed circular. Now, with an elliptical orbit, that means that the distance between Earth and sun changes. Sometimes we are closer to the sun. That is what we call perihelion. Sometimes we are at our farthest distance from the sun, and that is aphelion. Well, perihelion occurred just a little over a week ago, and that would have been on January 2nd. And that would have been when Earth was closest to the sun. That's about 6 months after, on July 6th, when it was farthest from the sun. Now, if you think about that, one of the misconceptions people often have is that changing distance between the Earth and sun causes the seasons. And it does not. The distance is actually very small. It's only about a 3 million mile difference, which of course seems like a lot to us, but relative to the nearly 100 million miles that the Earth and sun are apart, it's just a small percentage. And while it would make a slight difference, it would become nowhere close to causing the seasons that we experience on Earth. In addition, if this were the reason, seasons would occur at the same time all over the world. And that means that you would have summer in the northern hemisphere and summer in the southern hemisphere at the same time. And we know that is not the case. Here we are just going into winter in the northern hemisphere. However, the southern hemisphere is beginning their summer and much warmer weather. And that's because the seasons on Earth are caused by the tilt of the Earth's axis and not the changing distance between Earth and sun. So here we get to see one circle in the sky, the 22-degree halo around the sun caused by Earth's atmosphere, and got to discuss a little bit about the changing distance in Earth's orbit between the Earth and sun, and how that really has no impact on the changing seasons. So that was our picture of the day for January 13th of 2024. It was titled Circling the Sun. We'll be back again tomorrow for the next picture, previewed to be There Be Dragons. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.